Hello dear students, welcome to our THATSIIT YouTube channel. We are going to start the session for the most awaited JEE Advanced 2023 exam. As you all have crossed the first stage of preparation, which is JEE Main 2023 successfully. Now it is the time for us to solve the tough questions, discuss the critical concepts of chemistry and learn the subject extensively. So far, whatever topics were discussed, hope are useful in understanding the acute fundamentals of each and every concept. So now with that motivation, let's move on and discuss the advanced level questions from the previous JEE papers, which are actually required the abstract thinking to solve them. At the same time, the questions aren't very easy. It's not that you're going to see the question, get the idea, put the formula and get the answer. It's not going to happen that way. You have to logically analyze each and every question. You have to interpret the data which is given over there, and then you have to solve the question. So it's not an easy task to complete. But at the same time, when you catch the core of each question, when you catch the trickier part of each question, I must say that these questions are not going to bother you at all. So let's start this session as early as possible. So these sessions are going to be completed in 15 days. At the same time, they are going to be as chapter wise. So today's session is all about the stoichiometry and states of matter, which comes in the 11th class syllabus. In the last 5 to 10 years, as we have seen that there are plenty of questions asked, especially from stoichiometry. The trends were to ask mostly on the equivalent concept during the olden days, but now the pattern has changed. The mole concept based questions are mostly asked in the JEE Advanced in the recent times. So let's get into the business. Let's start with our first question, which is again mole concept based. It's not very difficult as well, but to solve the question on mole concept, one must have the balanced chemical equation. You see, if you don't have the balanced chemical equation with you, better you go ahead with the equivalent concept. Now, when you look at the question, probably you will understand how to solve it. You can see tin has reacted with HCl to produce a salt, isn't it? And the entire amount of the salt had reacted with Y gram of nitrobenzene in presence of HCl to produce an organic salt as well. So you have to find the value of x. So to solve this question, one should have the balanced chemical equation. Alright, so let's write that balanced chemical equation, which is tin, you can see, is first reacting with HCl. You should be good at balancing, right? SnCl2 and alright, H2. This is the salt, which is actually the reducing agent, as we all know. When you balance the equation by writing the quotients, this is going to be 2HCl. It's simple equation. Now the actual task comes in the second step, like nitrobenzene is being reduced to aniline, that is amino benzene and its salt, because when you take excess of HCl, you know that you are going to get the salt of it. This is the organic salt which is mentioned in the question. So language is critical, question is simple, right? So what's happening here is that when you are carrying out the reduction process by using SnCl2 and HCl, here all in all the information would be usually about the tin and its compounds. Now you know that when this has acted as a reducing agent, it's going to get oxidized to SnCl4. Now this is the overall reaction that is taking place. However, balancing of the equation is very essential for solving these questions, right? You need to balance it by writing. You can see that depending upon the number of chlorines, as they are more than 4, obviously here comes the 3 moles of SnCl2. Alright, now you can see that how many grams of tin had been used. You can see that x gram of tin had been used. So number of moles of tin, we know that weight by molecular weight is number of moles. These are not basic level questions, so I anticipate that you already know the fundamentals. As per that, number of moles of tin would be weight by atomic weight of tin is given as 119. You see, we are going to reach out to SnCl2 from the tin because this is the common medium of reaction. So 1:1 is the mole ratio for tin and tin chloride. So you can see for X by 119, you know that X by 119 moles of SnCl2 would be produced as well. And that X by 119 is actually reacting in the second stage to produce 1.29 grams of the organic salt. You can see the mole ratio 3:1 is the mole ratio. So number of moles ultimately of the salt formed are 1/3 of X by 119, which is equal to weight of the salt, which is given as 1.29 divided by the molecular weight of the entire salt. That is, you can see the salt is something like, you know, C6H5 plus 3 8. There is one nitrogen and one chlorine, right? So this is the molecular formula. So accordingly you can write the molecular weight 72 plus 8 hydrogens plus 14 is for nitrogen and 35.5. So by simplifying this, you can get the value of X. Hope you understood. Simple mole concept, but the point is balancing is very important. For 1 mole of tin, you got 1 mole of SnCl2. For 3 moles of SnCl2, you got 1 mole of the salt. So accordingly, we have balanced it and got the right answer, isn't it? Right? You know, this is how we are going to solve the question. Hope you understood. You are following, right? Just bear with me. We are going to move on to the next question. All right. Let's see how to solve the next question. Yes. Check the next question, please. Question looks to be complicated. However, it's not so as it is. Looks to be complicated, but it is not so, because you can see the question is all about the acute basics of stoichiometry. That is law of or principle of multiple proportions. You can see that in chemistry, because you see law of multiple proportions may be also used in the other subjects, hence it is emphasized in chemistry. State that the two element, say P and Q in this case, when are forming more than one compound, then the ratio of their masses, right, you can see that the ratio of their masses of the second element which combine with a fixed mass of the first element will always be the ratio of small whole numbers. Now, this is the definition part which I wanted to give you, as you have already understood and learned from the intermediate textbooks. I mean 11th and 12th textbook also have it. So in order to understand this law of multiple proportions, what we need to do is that we are going to keep the fixed mass of one element. You see, when more than one element are combining to give you more than one product. For a fixed mass of one element, the ratio of the masses of the element in the two different compounds is going to give you a whole number. This is the concept involved in it. So you can see we are going to fix it up first. We are going to rewrite the table for the compound 1 and 1, 2 and 3. You can see we are going to write this for the 50 grams, let's assume, of Q is being taken into consideration, right? For 50 grams of Q, we are going to convert how much of the P is going to be taken. You can see, as you could see, 50-50 is the ratio. So 50-50 for 50 grams the quantity is mentioned. For 55.6, as you could see, 55.6 the amount of P is 44.4. Therefore, for 50 grams of the Q, how much weight do we have to take, right? You know, that part we need to calculate. So I am doing the calculation part so that we can quickly get to the answer, right? You know, what's the answer? 50 into 44.4. We are going to rewrite the table, right? 55.6. So this is approximately 40% of what you call the P. Then we are going to rewrite it for this also. As you could see that for 60 gram the P is 40 gram. Therefore for 50 gram it would be how much? So this is simply turning out to be, when you simplify it, is turning out to be how much? 33.33. Alright, you can simplify that and check, right? 33.33. So you have rewritten the table for your comfort so that you can, law of multiple proportions can be obliged, right? You can see as per that, look at the options which are given according to it. If the empirical formula of a compound 3, see, we are going to take these values for compound 3, isn't it? For P, percentage of P and percentage of Q, this is compound 1, this is 2, and this is 3. What you're going to do here is that the empirical formula of the compound 3 is P3. You see, I'm checking out the option A. Please listen carefully. Complicated topic, right? P3Q4. We are going to fix up this with what you call. We are going to compound 3. This is compound 3, and this is compound 2, isn't it? So we are going to bring out to the same value of these two, and then we are going to compare the masses as per law of multiple proportions, right? So let's see what the mass of this thing is. So this is I'm going to bring, so what this will become is that 15 and Q20, alright. So this is P3 Q5. Then I'm going to divide this whole equation by 4 so that I get 5 units of the Q, because we are going to fix one element and we are going to find out the mass ratio of these two elements. How much is that in the compound 3 versus compound 2, right? 15 by 4 divided by 3. This is the mass ratio of 3 versus 2. Over here it is like, 33.33 divided by 40. So we have to check, are they turning out to be equal or not, isn't it? So this is turning out to be 5 by 4, however this is 5 by 6, so they are not matching, isn't it? So option A is incorrect. Simple law of multiple proportion is being taken into consideration, alright. You know how to sort out the option B then, alright. So I hope you understood how to do this part. So let me use this space as much as possible. Hope you understood this part. So I am going to sort out the option B over here. What is given here for the empirical formula of the compound 3 is P3Q, how much? Q2, and the atomic weight of P. Let's check, right? According to these values, according to the second table, we are going to work out on the second table, right? You're given for compound 3, isn't it? This is compound 3. So the elements P and Q are being taken. The mass ratios are respectively 3, 3 and 50. Alright, so what we are going to do in order to find out the empirical formula, we are going to find out the relative number of atoms in the next step. Relative number of atom means divided by its atomic weight. When we are going to do that, the atomic weight of the element P is given as 20 and that of Q is 45. Alright, okay. So now you can see these values, you will get these values and you will find out the simplest ratio, right? Let me do it for you. 33.33, you can do with the table one also, it doesn't matter. 33.33 divided by 20, 1.66. How much is this? 1.66. Now 50 by 45, you guys can quickly do it. By 45 is 1.11. Now we have to divide it with the simplest value, 1.11, 1.1, smallest value. So 1.66 divided by 1.11, turning out to be 1.5. This is how much? 1.5, and this is 1. Therefore, the empirical formula is P3 by 2, that is 1.5, and Q1. So this is P3 Q2. Alright. Alright. Hope you understood. So right answer for this question, if the empirical formula is P3 Q2, then atomic weights of these two elements is being justified. So right answer for this question. Hope you all have understood the option A and option B. Then accordingly you sort out the next option, isn't it? You're going to do that, right? You can look at the size of the question and don't get panicked by looking at the size of the question. The sizes are given so huge so that you get confused with the versatile data which may be put here and there. To check the psychology of a student, is he getting distracted or is he really solving or she really solving the question with interest or not. So the purpose of the lengthy question is to just confuse you by dumping some excess information or data, nothing else. You look at this question, you can see what's happening there. What is that? Ammonia is prepared by ammonium sulfate. We all know that, man, right? Ammonium sulfate and reacted with calcium hydroxide and you are going to get what? Calcium sulfate, as we know, plus ammonia, isn't it? Because there are two nitrogens and you're going to get water. I'm not concerned about the whole thing that is happening out there. The next equation is that when this ammonia is formed, it's going to be treated with NiCl2.6H2O plus, you can see, ammonia is giving rise to a stable coordination complex. So nickel ammonia coordination complex is something that is being discussed. So it is NiNH3 taken 6Cl2. You can see there are 6 ammonia ligands present, so it is 6 ammonia that are present. So the only point is that you should know that the stable ammonia complex of the nickel usually shows the 6 coordination. You know that it forms the complexes with 6 coordination, mostly with the ammonia as the ligand. See, this is the only point one has to learn. And how do we ascertain that it has to be 6? You can see over here that it is hexahydrated. So it is embedded in the octahedral void, which exactly takes place over here. So this is a hint. This serves as a hint to know that it is 6 coordinated complex. Alright. Now we can see, now coming out of the question, if one, how much is that? 1584 grams of ammonium sulfate, right? 1584 grams of ammonium sulfate and 952 gram of nickel are used in the preparation. 100% completed. And is there any amount regarding the calcium hydroxide is mentioned? No. So 1584 divided by the molecular weight of this thing, 36 plus 96. I am not doing the calculation part, which will waste your time. So let's do directly the question solving. Alright, now we can see that we need to end up at the 952 grams of the complex, right? So what is that we need to find out? Assume both reaction if the as with precipitation, the combined weight of gypsum, right, and nickel that produced is, so the weights are asked, isn't it? So gypsum, that is CaSO4 weight, and nickel ammonium complex weight. Alright, so we are not concerned about the half H2 or 2 H2O thing. So 1 mole you have to balance it, isn't it? You can see 1 mole of this giving rise to 1 mole of calcium sulfate. So straight away, so number of moles of calcium sulfate that are formed is 1584 divided by this is 132. Alright, so you got the answer for the number of moles of calcium sulfate. Now you need to, you can see, you can link up this ammonia. Ammonia is a common substance between these two reactions. So 1 mole giving rise to 2 moles. So it is 2 into 1584 by 132 moles which is formed, right? I am writing the mole in every case. Alright, so mole in every case. How much of this thing is reacting? 2 into 1584 by 132. Now you can see two substances are given, two weights are given, then we need to use the limiting reagent concept. As you could see in my videos, there is a concept called as limiting reagent. The reactant which is 100% consumed during the course of reaction. That means the reactant that produces the least. What is that? The reactant that produces the least is actually called as the limiting reagent. We need to check, right? 952 gram means divided by the molecular weight of nickel chloride we need to get. You can see, alright, nickel is 59 plus 71 plus 6 into 18. So this is the weight, molecular weight of the substance. So these are the number of moles of nickel chloride. So from nickel chloride, you have to check how much of the substance is produced. 1:1 is the ratio. So if nickel chloride is the limiting reagent, these are the number of moles that are formed. Similarly, if ammonia is limiting reagent, 6 moles giving rise to 1 mole. So number of moles of the nickel complex which is formed, which would be formed, is 1 by 6 into 2 into 1584 divided by 132. So among this value and this value, we have to check the smaller one is the right answer. Hope you understood. So whichever quantity is less is actually the product of the amount of the product. Hope you understood, right? Not so tricky, it's simple mole concept, man, right? It's all in your mind. Stoichiometry, psychometry, right? Everybody is scared of this chapter, but I making it very simple for you. You need to understand what's happening there. You know that copper plus 2 is over there, If you compare the copper plus 2 and copper plus 1, because of D10 configuration, copper plus 1 is more stable, 3D10, alright, plus I2 you can see copper got reduced, so something must be oxidized, plus KNO3. So this is the whole thing that is happening out there. You need to balance the equation, right? So I am writing here the balanced equation plus 4Ki giving rise to that is your part, man. You need to carry out the balancing, where every question is given 2 to 3 minutes time and you have got ample time to solve this question. You can see when excess of Ki is being taken, you are going to get Ki3, which is I3 minus, you know, that is a strong oxidizing agent which is oxidizing sulfur into from -2 to 0. Alright, so these are this plus Ki plus Hi. So looks that the second equation is balanced. When it comes to the third equation, you're going to write I think to Hi, that will help us. Okay, so this is how we are going to write the equation first, and you're going to do the whole thing by simple mole concept only. Weight by molecular weight of the substance is copper is 63 plus 14 into 40, 62 into 2, right? 62 into 2 is 124. Alright, so these are the number of moles of copper nitrate. From here you need to get the moles of iodine. You can see the number of moles of iodine are exactly half. How much? Exactly half. How much? 3.72 divided by 2 into, this value is turning out to be 192, isn't it? Am I right? So these are the number of moles of iodine. 1 mole of this thing is giving rise to 1 mole. So the same are the number of moles of Ki3, 3.72 divided by, I'm not doing the calculation part, man. So you can see you need to find out the another precipitate. You can see it's a balanced equation. 1 mole gives rise to 1 mole. So 3.72 by 2 into 192 are ultimately the moles of sulfur into atomic weight will give you the weight of the sulfur, which is a yellowish white turbidity, right? So this is the weight of the precipitate which is being asked, right? So brown color solution is because of this mixture. Little bit of inorganic chemistry knowledge is also required. Question looks to be lengthy, but there is no matter involved in it. You can see that oxalic acid, that is H2C2O4, is titrated against NaOH. Alright, you know that it's a dibasic acid, hence you will require the 2 moles of NaOH. We don't care the remaining things, right? You can see that number of moles of oxalic acid, that is molarity into volume. So this is nothing but number of millimoles, right, of oxalic acid, isn't it? Now what is that you need to find out? Molarity of NaOH. It's a very simple question. 1 mole giving rise to 2 moles. So 0.1 into 5 millimoles gives rise to 0.2 into 5 millimoles of NaOH, which is equal to molarity of NaOH into volume of NaOH. You can see that for 3 successive values of the NaOH, the solution remained as the constant indicator or end point. So for the constant values it is remaining, means the volume at the end point, that means is 9 ml. Alright, from the data we can ascertain this is the right. So at 9, you can see for different experiments we are getting the end point, that means the change in the color of the indicator. For out of 5 experiment we got, for 9 you can even take the average which will be close to the 9 and you can do that, but I am taking here 9 and getting the answer. So it's a simple question, isn't it? Hope you understood. Some questions are lengthy but they don't have any matter inside them. You can see 5.6 gram of iron is completely dissolved in cold HCl to prepare 250 ml. So there is a solution of, you can see solution means it cannot be raw iron, isn't it? It has to be the salt of iron, right? Plus 2 everywhere mentioned means salt of Fe plus 2. Actually we took 250 ml. For titration you won't take that whole amount, rather you will be taking 25 ml of Fe plus 2. Alright, how much? 25 ml, and this was titrated with what? The KMnO4. I hope in the acidic medium, isn't it? Yeah, HCl is taken. And as we know, in acidic medium, manganese changes its oxidation state from +7 to +2 as we have studied, but iron gets oxidized only till +3. So N factor, that is the change in oxidation number, +2 to +3 is for iron +2 it is 1, manganese +7 to +2 means the N factor is 5. So I am going to use here slightly different equivalent concept. As per that, the gram equivalents of the oxidizing agents, that is KMnO4, equal to the gram equivalents of the reducing agent, that is Fe+2. That's all. This is the core of the question, right? Nothing else. So gram equivalents of KMnO4 means molarity into N factor gives you normality. 5 into volume, I am taking milli equivalents, is equal to what is that? The number of moles of Fe+2 present, x into 10 power minus 2. These are present in 250 ml. Here the titration was done for 25 ml. Remember this. These are present in 250. 25 ka kitna hoga? How much will it be? Into 25 divided by 250, right? Isn't it? That is divided by 10 into the volume of moles only, na? Moles into N factor, right? Directly the number of moles are given, but moles in 250. 250 is x into 10 power minus 2. 25 is how much? Alright, so 25 into x into 10 power minus 2 divided by 250, that is 1 by 10 of x into 10 power minus 2. So you have to get the value of what? The x. Simple question. If you get the concept, you will understand how to solve them, isn't it? Next question looks to be again mole concept based. How you are going to solve P4 is boiled with a very famous reaction of the properties of NaOH, which is there in the textbook, such as your intermediate textbook, that is 11th and 12th, and also it is there in Opitandon textbook, right? Alright, so one should know here NaH2PO2 and pH. You can see the gas is mentioned. Alright, so here balancing is very essential. So balancing gives rise to what? Total 4 phosphorus are required. So we are not concerned about that water part. I think water also will be there because they are total 6 plus 3 9. Only 3 were taken, so 3H2O is also there. Yes. Then copper sulfate, when is reacting with that gas, you know, you will be getting Cu3P2 and H2SO4. These are the reactions that you need to know if you want to solve the questions, right? You can see there are 3 coppers and 2 phosphorus. As you can see, 1.24 number of moles we are going to find out, divided by 31 into 4, that is 124. That means, so 1 mole giving rise to 1 mole of pH3. So 1 by 100 means 1 by 100 mole of pH3. Now 1 by 100 mole of pH3 is being taken. 2:3 is the ratio, or 1:3 by 2. So the number of moles of copper sulfate are 3 by 2 times of 1 by 100, that is 3 by 200 moles. So this is the number of moles of copper sulfate. If the question is in mole, you do it, otherwise you multiply that with the molecular weight. I hope you understood. Making it very simple, isn't it? As simple as possible. Questions are lengthy, questions are difficult, but we are sticking to the idea. Simple mole concept, balancing, and just bang on. Same question, aluminum reacts with sulfuric acid. We have studied in our childhoods, right? So I am not kindling aluminum sulfate plus hydrogen gas. Again, limiting reagent funda looks to be there. So 2 moles and sulfates are 3, and 3 balanced equation is required. So how much of aluminum was taken? 5.4 divided by 27 moles, right? Molarity into volume in liter. This will give you the moles of it. So limiting reagent concept, 2 moles gives rise to 3 moles. If this is limiting reagent, you will be getting 3 by 2 times of 5.4 by 27. Alright, because 1:3 by 2. You can see it is 3:3. If this is limiting ingredient, you're going to get same, right? 5 into 50 divided by 1000. Isn't out of these two values, you have to check which one is less, right? You can see that 27 is 0.2. This is turning out to be 0.3, and this is 50. Goes how many times? 20, right? 1 by 4. 1 by 4 means point. Am I right? So this value is less, and these are the number of moles of H2, right? So this is the right answer. So number of moles of H2 is 1 by 4, which is equal to P into V by R into T. STP almost. So you can do that, right? So you find the volume of H2. Simple question. The only point is we need to get the, alright, limiting ingredient concept. I have released one video at the beginning itself. It is in the playlist of my videos. If you have subscribed, please watch my videos regularly. You're going to learn a lot. I'm going to give you the simplest techniques which are possible to solve these questions, isn't it? Now you see another easy question. Mole fraction of urea. You know the formula of urea, isn't it? Don't you know? Containing 9 grams of water is 0.05. Then you have been asked to find the molarity of urea solution. So I'll assume that let the number of moles of urea equal to some x. Therefore, you can see x divided by x plus 900 by 18. Mole fraction of urea was found to be how much? 0.05. So you have to get the value of x, which is nothing but what? The number of mole of urea that is solute. Now we can see density of the solution is given, isn't it? So you have to find the weight of solution. So what do you mean by weight of solution? Weight of solution equal to weight of H2O plus weight of urea. That is 900 plus 60 into x. Why 60 into x? Because molecular weight of urea is 60. Number of moles into molecular weight will give you. But you already got the value of x from here. You are going to substitute here to get the weight of the solution, isn't it? Now you can see the density. That is 1 cm. Alright, you got it, isn't it? Now you have to find out the molarity of the solution, right? So molarity equal to number of moles of the solute by volume of the solution in liter. How do you get the volume of the solution in liter? You can see 1.2 gram is present in 1 centimeter cube solution. This is the volume. Therefore, 900 plus 60 x grams of the solution constitute how much value? So volume of solution is 900 plus 60x divided by 1 point. So number of moles you got, that is x divided by 60x divided by 1 point, right? Isn't it? But this is given in milliliter. You have to convert that into liter by dividing it with 1000, because volume in liter should be taken, isn't it? Hope you understood. Easy questions, isn't it? Only the language is critical, lengthy, rest all looks to be easy. So follow my classes. So that is the troublesome stoichiometry part which had been discussed in the, which had been asked in the last 5 years or so. Now coming out of the gaseous state, it's much easier unless you make it complicated. Let's see how. This is kinetic gas theory, which is also studied extensively in, don't you think in physics also you study this very extensively? Alright, so average translational kinetic energy, that is 3 by 2 into kT of a molecule in gas at equilibrium versus RMS speed. As you know that RMS speed formula is under root of 3RT by m, and the average translational kinetic energy 3 by 2 into R by N into T per molecule, right? Now check the options. At a given temperature does not depend upon the molar mass, like there is no molar mass term. Which of the following are correct, right? So A is correct. RMS velocity is doubled when the temperature is increased 4 times. You can see that RMS velocity is directly proportional to under root of temperature. So when this is made 4 times, all right, am I right? Let's see. The doubled when the temperature increases 4 times, like you can see it is directly proportionate. It is doubled, that means this is also doubled. So C cannot be the right answer. RMS velocity is inversely proportional to square root of, yes, that is true. You can see over here, right? So this also looks to be okay. Let me do that, right? U1 is directly proportional to T1 and U2 is directly proportional to under root of 4 T2. So U1 by U2 is equal to how much? 1 by 2. So U2 equal to 2 times of U1. Yes, it is doubled when the temperature is increased 4 times. So A, B and D are the right options. Simple IP question, intermediate textbook question, 11th class question. All the questions are very simple. Only the point is they are given the huge diagrams, huge reactions, equations, graphs, etc. Just to panic you, man. That's all right. There is nothing depth involved in it, right? One thing only you have to understand, that if you read it thoroughly, because you've got plenty of time, you can play the game safely. Like, you know, the guesswork will not work out anyways, right? Because the questions are critical. So only one thing you should have is perseverance, endurance. So sit comfortably, sit leisurely, peacefully, and try to solve the question. If you can get the information from the question, you got the answer. That's it. So you can see there are 2 compartments. By looking at the image, don't get panicked. There is no jumble. They just panic you. There are 2 containers, right? 2 gases maybe, right? Ideal gas partition, 2 compartment is fixed, and in all such type of questions one has to understand that it is somewhat related to the number of moles, right? Even if you open that gate or close this gate, or if you move these gates, tilt this, whatever you do, the total number of moles constant, unless there is any heat change or temperature change is involved. You have to solve these questions by using this fundamental concept. Let's see. So what's happening here? Heat insulator, so that heat doesn't go out. If the old partition is replaced by, actually this is fixed, this doesn't move. So this moves, this can be moved here and there, alright, but movement will change only the volume but not the total number of moles, isn't it? Now let's take A and B, alright. So here the data says that the volume is 1. So I'm going to write the number of moles of A, right? PV equal to nRT. So number of moles equal to PV by RT. Pressure in this case is 5 into volume is 1 by 400 into R, and over here it is NB. Pressure is 1 into 3 by 300 into R. Therefore total number of moles Na plus Nb going to be 5 by 400 R plus 3 by 300 R. Now this is your case 1. Now coming out of the case 2, now you see this had been say moved by a distance of say some x. So let the volume this side equal to x. The total volume is going to remain constant, that is 1 plus 3. The total volume is 4 meter cube. So if this volume is assumed as x, so this will be what? 4 minus x meter cube, isn't it? So I'll use the concept, because the rest of the things are constant. So I'll use the concept P is directly proportional to temperature. So PA by TA equal to PB by TB. Alright. So you got the values of the Na and Nb from here. Alright. So you got the values of Na and Nb from here or not? Alright. So what you are going to do here is you are going to apply the concept that the relation between pressure and temperature is remaining intact, right? So PA by TA equal to P by TB. Over here you see the pressure will certainly change, isn't it? The pressure changes or not. When you are making a change, suppose you made a change, this has been moved forward, then definitely the pressure will change. Alright, temperature over this side is always remaining as what? 400, and over that side is always remaining as 300. It's not being said that the temperatures are changing, it's being said that only the volume part is changing. So by using the number of moles of, so let me take out this thing because we don't require this, we can find out, right, the pressure part. Over here what is happening, number of moles are constant, right? Over here the pressure is PA, over here the volume is, we assumed as at X. This is the old case and this is the other one is new case. This is the new case that I am talking about. PV equal to number of moles are going to remain anyways same, boss. They are just moving here and there into RT, right? 400 into R. So your 400 into R got cancelled. So PA is turning out to be what? 5 by X. So over here it is 5. Am I right? P into V equal to, yeah, 5 by X. Similarly, over here PB into the volume now is 4 minus X is equal to N is 1 by 3, 300 R into 300 R. It got cancelled. So PB is turning out to be how much? 3 upon 4 minus X. That's all. So we have to solve for X. Looks to be complicated, only the fundamental. Focus on the concept, right? Have any doubts, please post it in the comment box. Look at this simple question. One question may be difficult or lengthier, the other question is not. The question seems to be very simple and easy, isn't it? You can check this question, right? As we know, the ratio of most probable velocity possessed by maximum number of molecules. So this is your most probable velocity. Alright, then highest velocity is RMS and average lies somewhere in between. As we know that the ratio of the RMS, average and mean most probable velocity would be 1 is to 0.92 is to 0.82. Here the ulta of that or reverse of that is asked, most probable, average and the RMS. That means what I'm going to do is I'm going to divide the whole thing by this. I'm going to check what's going to be what. And I'm going to answer it, right? So 0.82 by 0.82. So I'm going to put it for upfront. So answer seems to be option B, and I want you to check out, right? So these are the questions which were asked in JEE Advanced from Stoichiometry and States of Matter. I hope you are liking the video, so please press the like button and share it to your friends who are also appearing along with you for JEE Advanced. And if you are new to this session, please subscribe and click the bell icon so that whenever I am posting, I'm going to post the video which is useful every day almost. So I want you to just keep a view or watch. Alright, keep watching my videos. That's it for today.